Hello students, myself Kiran TR. I am here to teach you an interesting and exciting topic in science, electricity. Let's go. Heating effect of electric current. Cell. Cell is a source of energy, electrical energy. Due to cell, the chemical reactions inside the cell, there is flow of electric current, flow of electrons. This cell in an entire circuit produces electric current, that is, it releases the energy. So the energy released by the storehouse is cell. In this circuit, here we have a cell. The energy which is released by the cell, what happens to it? Two things happens to the energy released by the cell. One, it is utilized to make some useful work. The second, a part of the energy which is released by the cell gets converted into heat, and this part is called the heating effect of electric current. Cell, source of electrical energy, flow of electrons. The energy released by the cell is utilized in two ways. One, to do the useful work. The second, it gets converted or dissipated in the form of heat. So this part where the energy released by the cell becomes heat is called the heating effect of electric current. You might have noticed when you use your mobile extensively for a long period of time, you will feel it's heated. Or the same phone, when you put to a charge, since the battery is low than 10%, you charge it. The charge keeps on increasing. By the time it reaches 100 or above 90, you will feel that your phone is heated. Why is that? It's because a part of the energy released by the cell, the battery, the source, is getting converted into heat. The rest of the part is used for making useful work, that is charging your battery. Rotating of a fan. A part of the energy released by the source of the cell is used for rotating a fan or lighting a bulb. You will notice it that if you leave the fan or the bulb to run or to be used for a longer time, 6 to 7 hours, then you touch the fan or bulb, there is heat. You can feel heat. What does this shows? It states that the energy released by the source, the cell or the battery, has the ability to produce heat, to dissipate heat, which is called the heating effect of electric current. We will derive at the equation for heat, H. Let us see the derivation. Here we have a circuit. In this circuit, we have cell, a key, a meter, a resistor with voltage across it. Now when we switch on the key, the current starts to flow. Let us consider that a charge or an electron is at position Q1. Now to move an electron from position Q1 to Q2, the cell has to expend its energy, that is, it has to do work. Now the work done by the cell or the battery is nothing but the energy. Work done is nothing but the energy, which is V into Q, the voltage and the charge multiplied. V into Q is the work done, W, to move the charge or an electron from position Q1 to Q2. Now we know what is the amount of work done, which is represented by the formula V into Q. What is a power source? The power source is V into Q divided by T. The P is equal to V into Q by T. What is T? T is the time taken to move from one point to another point. So here we have an electron at Q1. Now we have to move this electron from Q1 to Q2. So there is a time. So there is a time gap in which a charge moves from one position to another position. That time is called T. So when we consider the time, we get power. So the power formula is V Q by T. We also have another form of equation for the power for the entire circuit, which is V into I. We label that as equation 2 and we label V Q by T as equation 1. So here we have two equations. P is equal to V into Q by T, first equation. P is equal to V into I. We just need to keep on replacing things in the entire derivation. Now using equation 1, what is VQ? VQ is the energy. So we'll keep VQ, work done, the energy there itself, and take this T towards our left hand side. So division becomes multiplication. So we have P into T. The first equation can be written as V into Q, that's the energy, work done, is equal to P into T. Now we'll put the second equation in the first equation where we have P. The power according to the second equation is V into I. So we'll replace the power P as V into I. So the P becomes V into I into T. Now this VQ is nothing but the work done, the energy which is released by the cell. So this energy can also be called as the heat energy. One, the energy which is used for doing work. The other is heat energy. Both are energies. So the work done, V into Q, which is the energy, here we'll be considering it as heat energy. So V into Q becomes H. The energy becomes H. So we have the formula, which is the third equation, H is equal to V into I into T. Now we'll apply Ohm's law to this. When we apply Ohm's law to this, according to Ohm's law, we know V is equal to I into R. So in place of V, we write I into R. So the V is replaced with I into R. So we have two I's, the one I here and the other I. I into I is I square. So H is equal to I square RT. So this formula is known as Joules law of heating. So in this derivation, we just have replaced V into Q is equal to P into T. The P becomes V into I. V into Q, we are labeling that energy as heat. Again, V according to Ohm's law becomes IR. So by replacing the equations, we arrive at the final Joules law equation formula, which is H is equal to I square R into T. What is Joules law saying? Joules law is saying that the heat produced in a resistor is directly proportional to current. The heat produced in a resistor is directly proportional to the square of the current. The heat produced in a resistor is directly proportional to resistance, and the heat produced in a resistor is directly proportional to the time taken. Now let us consider the first assumption, that heat is directly proportional to current or square of current. How is it true? Let us make this assumption into a practical understanding. Now let us say the electric current I is flowing because of this particular battery. Let us say the voltage of this battery is 12 volts. Or the cell. Now let us increase the power of the cell. The power of cell, let us increase from 12 volt to 20 volt. This is just imaginary values. So now we have increased the voltage value of the cell from 12 volt to 20 volt. Now what happens if we replace this with 20 volts? What happens to the current? current increases in the entire circuit. So when the current increases, when there is more flow of electrons, what happens to the heat produced in the resistor? The heat produced will also increase. Second, the heat is directly proportional to resistor. Here we have a single resistor. What we will do, we will place one more resistor. So somewhere here in the circuit, not only a single resistor, we will add one more resistor or more than one resistors. So instead of one resistor, if you place more than one resistor, two or more, what happens? The resistance in the circuit increases. So when the resistance increases, the heat which is produced also increases, because there is long or more number of heat energy which is released. Now heat produced is directly proportional to the time taken. So what is T? The amount of time to move from Q1 to Q2. So if Q1 is here and Q2 is here, and we take time only 1 second to move from Q1 to Q2. So to move from Q1 to Q2, the time taken is 1 second. Let us take another scenario where we have Q1, we have Q2, and the time taken to move from Q1 to Q2 is 5 seconds. Now here the time increases. So if the time increases, then the heat produced in this circuit will also increase. So the heat produced in a resistor is directly proportional to the current, resistance, and the time. This is Joules law. According to Joules law of heating, the heat produced in a resistor is 1. Directly proportional to the square of the current for a given resistance. So when a resistance is fixed, it is directly proportional to the square of current. It is directly proportional to the resistance for a given current. It is also directly proportional to the time for which the current flows through the resistor. So directly proportional to the time. If any of these three increases, either the current, square of the current, resistance, or the temperature increases, what happens to the heat produced in the resistor? The heat will also increase. If either the square of the current, the resistance, or the time decreases, the heat produced will also decrease. This is about the heating effect of electric current. Where do we use this heating effect of electric current? Practical applications. The one most important thing which hits our mind is electric iron. So to iron our cloths, there are a large number of resistors which are kept in the circuit, due to which large amount of heat is dissipated to the iron box, and we can iron the clothes. The electric oven, the toaster, the electric heater are all the practical applications and uses of the heating effect of electric current. Electric current is also used in bulb. Right now we are in the era of LED bulbs. Before there used to be filament bulbs. The filament which is inside the bulb, the heat which is produced is being converted into light. So the filament of the bulb, the heat produced by the electric current is also leading to produce light. Fuse, another important application of heating effect of electric current is fuse. Now what does this fuse do? If there is a sudden increase of current, if there is more current which suddenly rushes in your homes, you might have noticed the bulbs burst or the fan suddenly stops functioning. So why does this happen? Because there is a sudden flow of current in your home, or there is a sudden increase in voltage, power in your home, which damages all the electric circuits. So if you place a fuse, what does the fuse do? It converts the energy into heat. So it gets dissipated. The more electrical energy gets dissipated as heat. And there comes a point where if the fuse cannot withstand the heat, it bursts. So more heat, the fuse bursts, and it protects all the other devices. So fuse is another example for heating effect of electric current. The energy is converted into heat and it protects it. Protects all the other appliances such as fan, bulbs, TVs in your home. The practical applications of heating effect of electric current: electric iron, electric toaster, electric oven, electric heater, to produce a light in the bulbs, and the fuse in electric circuits. If you love to learn more and need more of these videos, click on the subscribe button and the bell icon next to it. Don't forget to like, comment, share. Love you. See you in the next video.